Hello everyone, welcome to day 3 of CCNP series. This is day 3. In last video, in day 2 of CCNP series, we had discussed what is ipv6, why we come up with ipv6 and simplification of ipv6, how long ipv6 address is, how to write ipv6 address, representation of ipv6 address, and today in day 3 we will discuss types of ipv6 address, and we will discuss how device will calculate link local address automatically. Actually, whenever you will configure ipv6 address on the interface of any device, the device will automatically calculate local link address to communicate in LAN, in local area network, to communicate in same network. Okay, so we will discuss how device will calculate link local address. This is very interesting, right? So today in this video we will discuss how device will calculate link local address, and then I will show you how to configure ipv6 address on the interface of router. In GNS3 I will show you how to configure ipv6 address as well, and how to check ipv6 address as well. Okay, so first of all, you can see we have 3 types of address in ipv6: unicast, multicast, and anycast. In ipv4 we have 3 types of address, right? Unicast, multicast, and broadcast, but there is no any term like broadcast in ipv6. Okay, we have unicast, multicast, and anycast. Okay, these are 3 types of ipv6 address. Let me discuss one by one. First one is unicast. So unicast address uniquely identifies an interface on an ipv6 device. Okay, so identify a interface of ipv6 address, we will use unicast address. This is similar to ipv4 address, right? A source can be only unicast. Remember, in ipv4 a source IP address can't be a multicast or broadcast. In the same way, in ipv6 address, source should be a unicast. Source can be a unicast only. Source can't be a multicast, or source can't be a anycast. Okay, so here you can see a packet sent to a unicast address is received by the interface that is assigned to that address, right? Only that interface will receive that packet where you have configured or you have assigned that ipv6 address. Suppose, let me take one example. This is my router and here is one server, and suppose here I am running ipv6 address, and address is 2000:1/64, and here is my PC, and if I will ping 2000:1, right? So only this machine will receive this packet, only this server will receive this packet, because here only I am running this IP address. So this is similar to unicast address in ipv4. Okay, and in last line you can see similar to ipv4, source ipv6 addresses must be a unicast address, right? So source can't be multicast or anycast. Okay, now we have 3 types of unicast address. We have 3 types of unicast address. Like in ipv4 we have private IP, we have public IP, right? We have 3 types of unicast address, and first one is global unicast, second one is unique local, and third one is link local. So whenever you will configure any ipv6 address on interface, device will automatically assign a link local address. So we will discuss how device will calculate link local as well. So first of all, understand there are 3 types of unicast address in ipv6. First one is global unicast, second one is unique local, and third one is link local. Okay, so see, what is global unicast? A routable address in the ipv6 internet, right? So this IP address is routable on internet. that means this is similar to public IP address in IPv4, right? In IPv4 there are two types of address, private and public, but private IP address are not routable on internet. That's why on my edge router we have to run NATing, we have to perform NATing. Either you can configure NAT, PAT, static NAT, right, for the translation. That technology will translate your private IP into public IP address. So suppose this is my router, this is my ISP, this is Google server. So this is public network, am I right? And here I am sitting, this is my private network, here I am using private IP address, and my private IP address is not routable on internet. So that's why I will run NAT over here. So NAT will translate private into public, and when reply will come, then again NAT will translate public into private. Okay, so in the same way in IPv6 we have global unicast address. This is routable on internet. We can communicate with internet with the help of global unicast address. So here you can say similar to a public IPv4 address. It is similar to a public IPv4 address, and this IP address will start from 2000:3, and you can see guys, these 3 bits are reserved by INA. These 3 bits is assigned by INA. The first 3 bits 0, 0, 1 assigned by INA. So you can't change 3 bits, first 3 bits, right? If I talk about IPv6 address, let me take one example over here. Okay, so how long IPv6 address is? 128 bits address. It is an 128 bits address. Out of 128 bits address, 3 bits are reserved, 0, 0, 1, right? These are first 3 bits. In one field there will be 16 bits, right? There will be 16 bits, because in one field there will be 4 hexadecimal character, and each hexadecimal character carry 4 bit. So 4 multiplied by 4 is equal to 16 bits. So in one field of IPv6 there will be 16 bit, right? Out of this 16 bit, first 3 bits are reserved, like 0, 0, 1, and 4th bit are free. You can use 0 or you can use 1. So suppose 0, 0, 1, and here is 4th bit. So these 3 bit are reserved. What will be the hexadecimal value of this binary? If I will put 0 over here, so hexadecimal value will be 2, right? Remember formula 8421, right? So this is 1, all of rest are 0, that means it is 2. Okay, and I can change this value. I can change 4th bit. So if I will put 1 on 4th bit, then it will be 3. So any IP address which will start from 2 and 3 will be your global unicast address. Any IP address which will start from 2 or 3 will be your global unicast address. So 3 bits are reserved by INA in global unicast address, and this address is routable on internet. Okay, let me move on second type of address, that is unique local address. See, unique local address similar to a private address in IPv4. This is similar to private IP address, and again private IP address is not routable on internet. That means in IPv6 unique local address is not routable on internet, right? This IP address is not routable on internet, not intended to be routable in the IPv6 internet. It can be used similarly to a global unicast. Yes, it is similarly to global unicast addresses, but used for private use. So this IP address will be used for private uses only, okay, and should not be rooted in the global internet. So this IP address is not routable on internet. And you can say range start from FC00:7. So here in unique local, 7 bits are reserved by INA. How many bits are reserved? 7 bits. So let me take one more example. FC00:7. So here 7 bits are reserved, means if I talk about first field, in first field there will be 16 bit. Out of that 16 bits, 7 bits are reserved, right? 7 bits are reserved, means first bit will be 1, first will be 1, second will be 1, third will be 1, fourth will be 1, right? Then only I will get F in hexadecimal, right? So first 4 bits are reserved and 3 more bits are reserved, that is 1 1 1 0. This is 8 bit, this is 8th bit, these are 7th bit. C means what, guys? In binary, how you will write C? 12 will be 8 plus 4, 8 plus 4, 0 0. Okay, so this bit will be 0, this will be your 0. So these bits are reserved. So this is F and this is C, and you can change it. So if I will set 1 over here, 1 2 3 4 1 1 0 1, it will be FD, right? /7. So any IP address which will start from FC and FD will be your which type of address? Will be your unique local address. Okay, any IP address which will start from FC or FD, you can see over here, start with FC or FD in the first 2 number, that IP address will be your unique local address. This is how you will identify IPv6 address. In exam, many time examiner can ask you this type of question, that identify unique local address or link local address or unicast local address, right? Global unicast address. Okay, now third type of address is link local address. This is very interesting, guys. Okay, so see, link local address used only to communicate with a device on the same local link. So a device will automatically calculate one link local address whenever you will configure IPv6 address on interface. So why device will calculate automatically address, link local address? To communicate in LAN, to communicate in local area network, to communicate in same network, right? And it is an default IPv6 address on every IPv6 enabled interface, but again it is not routable. Yes, so this address is used to communicate in LAN network, in local area networks, though this IP address is not routable on internet. And range will be FE80:10, right? IP address will be start from here. So what will be the binary of F1111? What will be the binary of E? E means 13. E means 13, right? So how I will write 13 in binary? 8 plus 4 12 0 1, right? And after that 8 1 1 0 0 0, and in first 4 bit 1 1 1 1. So out of these 12 bit, how many bits are reserved? 10 bit. First 4 bit, and then second 4 bit, and then 2 bit, right? So these are reserved in link local, right? Here you can write 1 as well or 0 as well. We have 4 combination: 0 0 1 1 0 1 and 1 0. Okay, so this is range of link local address. Now here is very interesting concept, how device will calculate link local address. So we will discuss how device will calculate link local address. First of all, let me discuss multicast address and anycast address. Okay, so second type of address is multicast address. Multicast address is similar to class D IP address, right? Remember class D address of IPv4, right? It is similar to the IPv4 class D address, right? IPv6 multicast improves network efficiency by allowing a host to transmit a datagram to a targeted group of receiver, right? And multicast address, range of multicast address is FF00:8. Again, how many bits are reserved? 8 bit, right? So first 4 bits will be 11111 and second 4 bit will be again 11111. Okay, so 8 bits are reserved in multicast. And last types of address is IPv6 address. Guys, when I will implement IPv6 address in routing, while I will discuss OSPF, BGP or EIGRP, then I will show you how to implement IPv6, right? That time it will be that time you will use this type of address, right? EIGRP will use multicast address, right, to send their update, their hello message. Okay, so you have to just remember the range of global unicast address, link local address, multicast address, right? So range will be, starting range will be FF00:8 for multicast address, and last one is Anycast. So what is Anycast? An IPv6 Anycast address is an address that is assigned to more than one interface. So we can assign Anycast address to the multiple device, to the multiple interface. Okay, Anycast IP address, we can assign this IP address on the multiple interface. Typically the address belongs to a different nodes. A packet that is sent to an Anycast address is routed to the nearest interface that has that address. What is this? Let's see. Let me take one example. Here I am sitting. Okay, this is my computer, this is my router, this is connected to internet. Okay, and I want to access Google servers, and as you know, there will be thousands of Google server in the world. There will be more than thousands of Google server in the world. Google server will be in India as well. In India, this is suppose Google server of India, this is Google server of US, this is Google server of Nepal, this is Google server of Delhi, XYZ place, right? So I will configure same IP address on all Google server, right? And that IP address will be Anycast IP address, and all are connected through internet, right? And if I will ping Google server from here, so I will ping on Anycast address, and Anycast address will be routed to the nearest destination, right? So if I will ping from India, so my request will go to India server, and this one will generate reply. If this server will not generate reply, then my request will go to other server. So if I will send packet on Anycast address, right, so my packet will be reached to my nearest destination. This is the use of Anycast address. Now, how to calculate link local address? This is really very, very interesting. Let me show you first of all how to configure IPv6 address. See, let me open my GNS3. Okay, so hope you are able to see my screen. Let me take access of R1. First of all, I am going to give one IPv6 address on R1. On which interface? On F0/0. Okay, so first of all go to configure terminal mode. Guys, by default your device on my router IPv6 service is disabled. First of all we need to enable IPv6 service. So command will be very simple, IPv6 unicast routing, right? Like if you will run no IP routing command on your router, so your router will stop performing routing. In the same way, if you will run IPv6 unicast routing, your router will start performing routing for IPv6 address. Okay, after that interface fast Ethernet 0/0, and now there is no any IP address you can check. So IPv6, how to check IPv6 address? Command will be show IPv6 interface brief. Command to check IPv4 addresses, so IP interface brief, and command to check IPv6 addresses, so IPv6 address brief. And you can see there is no any IP address, right? There is no any IP address. Now let me configure one IPv6 address on fast Ethernet 0/0. So go to interface fast Ethernet 0/0, no shutdown, and IPv6 address. What will be the command? Command will be this one, IPv6 address. Let me configure 2000 :1/64. Guys, by default CIDR value will be 64 in IPv6. Means in every IP address 64-bit will be network portion and 64 will be host portion. Okay, in IPv6 we can change it, it will depend on you. It is just by default value. Okay, let me hit enter, and now if you will run so IPv6 interface brief and exclude unassign. So you can see over here IPv6 address is 2000 :1, but there is one link local address. This one is my link local address. I haven't configured link local address. This device automatically generate this IP address, link local address. Let me copy it, and first of all let me show you how device is calculating this link local address. Let me open Paint. Okay, let me paste it over here. This is my link local address. This is my link local address. Okay, let me show you how this device is calculating this link local address. First of all, let me show you the MAC address of this device, this interface. So interface fast Ethernet 0/1, and see this is MAC address. This is MAC address of this interface. Let me copy it and let me put it over here. This is MAC address of my interface. And guys, as you know, MAC address is again combination of two things. First one is OUI, organization assigned OUI. First 20 bits, 24 bits is OUI, organization unique identifier, and last 24 bit is vendor assigned. Okay, so first of all divide it into two part. First part is this one is OUI organization unique identifier, and this one is vendor assigned. Okay, first 24 bit is organization unique identifier and last 24 bit is vendor assigned MAC address. Okay, and between OUI and vendor assigned you have to put this IP this IP address is FFFE, right? And now we need to convert it into IPv6. So here you will put dual colon, after that here you will put dual colon, and here also you will put dual colon. So this one is address represented in hexadecimal, but this is not a link local address. This is not a link local address. What we need to do now we need to convert 7th bit. Which bit? 7th bit. Which one is 7th bit? This one is first 4 bit, this one is second 4 bit. So here if I will change it into binary, so see guys what I am trying to say, I need to convert 7th bit. So suppose if 7th bit is now 1, so we have to convert it into 0. If 7th bit is 0, then we need to convert it into 1. Okay, so first of all let me convert it into binary. So this one is C is my first 4 bit and A is my second 4 bit, right? So let me convert it into binary. What will be the binary of A? A means 10. 10 means 1010. So this one is first 4 bit, 5th bit, this one is 6th bit, and this one is 7th bit, right? This one is 7th bit. Let me convert it. So this is 1 by default, so I will convert it into 0 and rest will be same. What will be the decimal? Decimal will be 8. Okay, so now oh, just wait guys. Now A. So my after conversion of 7th bit, my address will be C8 1. Where is my MAC address? What is my MAC address? 01 na? Okay. See, my MAC address is CA01, CA01, and when you will convert 7th bit, right? So 7th bit, then you will get value 8 over here, right? Because binary of A will be 1010, and if you will convert it into 0, then it will be 1000 and it is 8, right? So now my new MAC address will be C801 colon 51 FE colon FF colon FE 50 colon 0006, and now we need to add this range. Where is link local address? Yes, so starting range, this one FE80 dual colon. So here we need to put what, and you know what, this is your EUI 64. This is your EUI 64, right? In EUI 64 you will add link local address. Let me copy it. This is my EUI, and here in starting we will put my link local address FE80 dual colon. Okay, so FE80 dual colon C810, and guys you can see, is there any difference between these two address? Both are same or not? So this is how you will calculate link local address. And let me access R2 as well, and let me configure IPv6 address on R2 also. interface F0/0, no shutdown, and IPv6 address is 2000 : suppose 2 and /64. So IPv6 interface brief. You can see this is my link local address and this is my IPv6 which one? Unicast global unicast address, right? Global unicast address range is from 2000/3, and now I can ping as well, and you can check the MAC address. So interface F0/0, this is MAC address. Here you can see MAC address. So this is MAC address. Now again, if you want to calculate link local address, what we need to do? Copy it. Let me paste it over here, and you can see the link local address of this router. So IPv6 interface brief. This one is link local address, right? What we need to do? Let me paste it over here. This is one. This is my MAC address. First of all, this first 22 bits are OUI, and second one is last 24 bit is my vendor assigned. Between OUI and vendor assigned, we will put FFE, right? And then here we need to put dual colon, 1 2 3 4 bit dual colon, here dual colon. Okay, and now on 7 bit, let me convert 7th bit. So 7th bit will be 8, and in starting we need to add F, this one. We need to add this one, FE80. So FE, where it is in starting, FE80 dual colon. This is your link local address. This will be your link local address. You can verify it. So IPv6 na. So IPv6 interface brief. This is your link local address. Copy it and let me paste it over here. See, is there any difference? No, both are same. FE80 F. Sorry, here I have write something wrong. This one will not F over here. This is my MAC address. So interface F0/0. You can see this is my MAC address C, starting from C, right? So yes, it will be your MAC address na. 8 and C802 73 FF dual colon FE4 dual colon 8. Okay, so this is how you will calculate link local address. Can I ping from R1? Let me check. Ping 2000 dual colon 1. Yes, I am able to ping. Success rate is 100%. Okay guys, so this is IPv6. Now when I will implement IPv6 in my network, when I will start routing. Okay, so that's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. Thanks for watching. We will meet soon. Till then, stay safe. Bye bye guys.